Morning, everyone. Morning, Eric. Morning, Logan. Morning, Kimmeline. Morning, Vinny. Morning, Hike. Happy Tuesday, Ava. Hi, Ryan. Hi, Azra. So, I already got the DNA whiteboard up. Agenda today is very similar to yesterday, so today's stream might be a little shorter depending on if you have any questions or not, or a lot of questions or not. In that, we are working on a DNA. The second one, we are going to quickly just go over again one more time the rubric, the goal for total solar system, and then finish your slides based on your planet. Hi, Charlie. Your DNA question today is describing and or defining an asteroid. So we've done a planet. We talked about Pluto being a dwarf planet. So kind of working backwards now to smaller and smaller objects. What's an asteroid? Think about the definition of a planet and what criteria it would not pass. So work backward from a planet, right? We said a dwarf planet failed criteria number 3. So just to remind you, oops, that's early. Hi, Maddie. Just to remind you from yesterday, they failed criteria number 3, right? Dwarf planets. In that it can't clear its own neighborhood of similar objects. It's in its own path, right? And so the other two criteria are being spherical and orbiting the sun. So out of being spherical, orbiting the sun, and clearing its neighborhood, which one do asteroids fail? Which ones do they pass? And could you use that to kind of come up with a definition for an asteroid? Which is what we'll do in a few minutes. But to kind of help you describe what they are, to visualize them, I have put down below as an attachment several pictures. So you can open those up when you want. I'm going to open up in a few minutes. We'll talk about what an asteroid is, and we'll move on to finishing the slide portion of Toll the Solar System. All right. Keep in mind that Tour of the Solar System, the recording, the writing of your narration of the slides, the document itself is due midnight on Wednesday, right before midnight. So almost into Thursday, but not quite. And then Thursday at midnight, or Thursday before midnight, your DNA sheet. Thursday itself, we'll kind of look at some of your presentations. Those of you that volunteer, I'll have a form for you to sign up. You can give me your link, tell me what planet you did, and then we'll look at presentations for each planet on Thursday, actual tour. And then Friday is just your quiz. That's it. Morning, Jake. Working on DNA number 2. They don't post new assignments. So I'm not getting into something new on Friday. It is old information from Monday to Thursday. Quizzes don't take that long either, do they? Alright. So let's take a look at some of these pictures, come up with a definition. First one. This is Eros. Asteroid in the asteroid belt. Kind of large. But if you were to describe this, what does it have on it? Any of you? How does this compare to your planet in terms of size and shape? How does this asteroid compare to your planet in size and shape? It's not spherical. All right, it's the big thing, right? Not spherical. Your object could have craters on it, which is impact with another object, but definitely spherical, right? Good job, Downey. Good job, Hike. All right. So then looking on further, at least it has something kind of like a sphere. This is Eros, smaller. This is a Psyche. I'm sorry, Psyche, a little smaller than Eros. Again, crater impacts, smaller objects like meteors. Two different lobes. Looks like it has two eyeballs. Yeah, I could see that. All right. Two eyeballs. This has two lobes. So it's like two different halves. Potato shaped. Smaller. Now, a few types of asteroids. So there are subtypes. We're not going to get into subtypes because we aren't going to do our engineering project that I wanted to do. It is landing a rover on a asteroid, but to do some mining. There are three basic types. M-type, like Lutetia, is heavy in iron and nickel. So maybe that would be something that you'd be interested in mining in the future. Different space programs or countries. C group or C-type asteroids, like Matilde, that is high in carbon. And then S-types are high in silicates. Silicates form the basis to form bonds between minerals. So lots of rocks and minerals, high in carbons and possibly organics. And then this is high in iron and nickel. So there's three basic types. The majority of asteroids are C-types. About 70%, almost 3/4. And then S-types are the next most common, and then M-types are the rarer. However, if you have an asteroid that is only 10% this type, that's still a lot of asteroids, as you're going to find out. So there's different subtypes. They have different shapes. None of them look uniform. This is different radio measurements. So using radio waves as like sonar, you can ping asteroids. This is an asteroid called Apophis, which in 2011 astronomers were worried might impact Earth in 2030 something, like 2039. I can't remember exactly. It's been a while. So there was a 2.7% chance that this asteroid would hit Earth, Apophis, and its size is I wouldn't call it like a world ender, but is very, very unnerving if it would actually hit Earth. They determined it is not going to hit Earth, but they did that by doing different measurements and observations of this asteroid. And it kind of looks like its shape is changing in each picture. That's because it is rotating. So these objects are tumbling almost, spinning as they move throughout the solar system. I'd have to look it up, Jake. You could look it up, size of Apophis. I don't know what unit that is. Near Earth asteroid with a diameter of 370 meters. So no, much, much smaller than Europe. Europe size would be like Vesta or even Ceres, which are not going to collide with us. So again, a little more observation. Um, and this right here makes up a third of the mass of the asteroid belt, Ceres. And these little bright spots right here, the orbiter Dawn did a flyby of some asteroids, Vesta, and then they went off to Ceres and they found these pictures and these little bright spots on there. Well, what is this? Because they never seen anything like this before on Ceres, and so they found out that asteroid or meteorite impacts onto Ceres, these little craters, these pockmarks, may have exposed ice underneath its surface. So these bright spots are ice or salt deposits, also very reflective, from water that did come up from below the surface. And that water sublimated away or evaporated away, left behind salt, or it's water ice itself. I won't say frozen water because that messes up Azura. It is not that you would have to go much, much further. That is not the molten core. But this is considered a dwarf planet. It was an asteroid because it was in the asteroid belt. This, however, is now a dwarf planet because it is spherical. This is a phase. Remember, this is the gibbous phase. So this is spherical under its own gravity, and it orbits the sun. However, it's in the orbit of the other asteroids. So, it's a dwarf planet. So, those are all asteroids. One of them is technically a dwarf planet. Can you define an asteroid now? It's not aliens. It's never aliens. If you want one more visual, here is a model made in 2005 of the inner solar system with Jupiter and the asteroid belt. The sun is the dot at the center. Mercury and Venus are moving so fast with Earth, you can't really make out where they are. Mars is slowly moving in its very eccentric orbit, and then Jupiter's out in its orbit. So there's a good gap between Mars and Jupiter. All right? As Jupiter is orbiting around the sun, in pink are the main asteroids, and then in green are other groups of asteroids. Call them the Trojans and the Greeks. Almost because they're almost like they're in the Trojan War, right? So, what is Jupiter doing to the asteroid belt? Maybe some of you can kind of make an observation in chat. So we've discussed their appearance. Now we're looking at their location. And this is all just going to finally define asteroid for us. Am I good now? It says I have audio now. I didn't before. No, I wasn't muted. I checked that, Charlie. I'm good? What the? Well, I'm sorry about that. It said it was fine. Alright, so back to here. Hopefully you guys, maybe you didn't hear me. I said Hike and Rainy, you're both kind of right. That Jupiter's movement prevents asteroids from clumping together. It's a shepherd. It pushes asteroids and pulls asteroids. And so these Greek and Trojan asteroids can't come together with the pink asteroids, the main asteroid belt, to form a new planet because of Jupiter's gravity. There should be enough space and enough material to form another planet between Mars and Jupiter. But we don't have that because Jupiter's gravity prevents them from colliding into one mass. So asteroids are kind of considered leftovers of planetary formation, and they don't form something new because of Jupiter's gravity. So it's kind of in short what I was saying. This is to help you think about where the asteroids are in the solar system, and then put it with a definition, which is what I was trying to write, and you guys couldn't hear me. Good with that? So an asteroid is a non-spherical object which doesn't have enough mass, enough gravity to pull it all in directions. How would that affect Earth if a new planet formed? If a new planet formed, depending on if it was in resonance or in an alignment with Jupiter and Mars, you probably wouldn't see much of an impact because gravity's effect drops off dramatically with distance. But you would have probably, with the collisions and the colliding of that object together into one body, Nikolai, you would have probably some stray asteroids going into the inner solar system, which crossing path with a planet would mean an impact at some point. So the planet itself wouldn't cause an issue, but maybe stray asteroids would. And if you're interested in what happens if the gas giants collide, I made a video on that. We'll watch another point. An asteroid is a non-spherical object, not enough mass and gravity, that orbits the Sun between the orbits of Mars and Jupiter. Because he likes learning, Charlie. So an asteroid is a non-spherical object, doesn't have enough mass or gravity to be a sphere, that orbits the Sun between the orbits of Mars and Jupiter. It is a leftover of planetary formation that is prevented from forming a planet by Jupiter. So it's kind of wordy. but it's everything that we've talked about, or I showed you today. Bunch of non-uniform, different shaped objects of different sizes, from, you know, the size of a table to the size of a dwarf planet to the size of some countries. And they're all in between Mars and Jupiter. They do cross the inner solar system sometimes, but they primarily are in between Mars and Jupiter because they're leftovers from planetary formation. Jupiter just formed first and has so much mass and so much gravity that Jupiter says, like, you're not making another planet, and it actually pulls groups of asteroids and pushes groups of asteroids around the solar system. So you might think Jupiter is a bully, but at the same time, it prevents asteroids, many asteroids, from crossing into the inner solar system. And so it's almost like a shield for Earth. If you didn't have Jupiter, you'd have more stray objects crossing into the inner solar system, which would be cataclysmic. So sometimes you think of Jupiter as a bully. That sounds bullyish. It's almost like a shield. And again, we think Jupiter and the inner, larger gas planets formed closer to the Sun, but have moved out over time to the positions that they're at. How'd that happen? Watch the video of what happens when gas giants collide. You haven't seen it yet? For your own interest, but we're going to use it for an assignment later. It's there. Also, if you're getting ahead and your slides are almost done and you want to just get tour of the solar system over with, so you have nothing else to worry about except for your DNA sheet for the week, there's a video on how to use Screencastify, which for some reason did not become clickable. There. So the first link is if the gas giants collided, how did they move from their current spot? And the second one is using Screencastify if you need tips. A couple people were brave and tried it on their own already. Alright. So we are now on our agenda right here in going over and talking about tour of the solar system. Oh, you missed it, Rainy. Everything's over. And at this point, unless you really have questions, it's going to be kind of a quick wrap-up, because you need the time to work on slides if you need the time to work on slides. If not, maybe start working with Screencastify. But that will be primary objective for tomorrow. All right? So, once again, you have this document. Tour of the solar system. You were to pick a planet in this box right here. You were to research it. You put your sources on the right. All right? There are 11 boxes here, which means if you make a slide for each box, there's 11 slides right off the bat. However, I think 2 of these slides could be put together, like surface conditions and specific landmarks or features. They're pretty much similar in content. And you could probably also put some of these astronomical research points together too, like definitely rotation and revolution, all right, or distance and surface gravity. You could probably put some of that together, all right. I would also include Earth as a comparison. I gave you the information for Earth to help you out, so if I give it to you, why don't you use it? All right. Questions so far? I'm gonna kind of keep moving, ask them as I go. When you're making your slides, yesterday I said to do half yesterday and half today. So you're working on the other half or finishing up the half that you're doing. So maybe you are at atmosphere, temperature, and weather. You're working on that, down to ring system, and then make sure at the end you put your sources in. Make an end slide with your sources on them. Okay? I don't need a full citation, just provide the links. Or you can provide the links as you go. So, you could do name of the slide, content on the slide, and then at the bottom of your slide, put your link. Okay? So if you want to take this as simple as it can be, category becomes the name of the slide, information is what you put on the slide, and then sources is what you put at the bottom of the slide. Alright? So there can be a very systematic way of doing this, or you can organize yourself however you want. This is open-ended to present information. Alright? When you record yourself, I suggest you put yourself into presentation mode. So, like I take my Pluto presentation. Screencastify goes away. You can't see it, but hit. Well, if I signed in, I could hit record, and then as soon as it's starting to count down, I hit present, and then I can just go arrow and arrow and arrow, arrow down, arrow over, and I can move from slide to slide. And it'll record my voice as long as the microphone's checked. Alright, I don't need to record your face. Okay? If you do not record yourself, you need to put in your box with your slides a little paragraph of you narrating, talking about your planet. Okay? So that's the overview of the assignment. Again, not in great detail, just a brief overview. The rubric is in classroom under classwork. 6 criteria, so 6 strands. The first 3 are content, so geology, meteorology, so the land or the gases, and the atmosphere, which is just all of it together if you're a gas giant. But each of these criteria, surface conditions, landmarks, interior, and weather, talking about astronomy, rotation period, revolution period, mass, surface gravity, and then miscellaneous, the moons, the rings, missions to the planet. If you don't have moons, if you don't have rings, go in depth on missions to the planet. Each planet has missions to it. Okay? The next 3 strands, slides, being organized, being able to use pictures appropriately, being able to use your sources. If you don't have sources, you lose a point automatically. Probably, maybe more, depending on the severity. If you just copied and pasted and then you gave no source, you're probably going to lose another point. Right? If you put it in your own words, like I can tell whose words it is, then you probably just lose 1. But give me your sources, because it's an easy thing to do, and you get your full credit. Communication, being engaging and informative, being able to talk clearly, all right, being able to write clearly if that's what you're doing, or also on the slides. Big walls of text are not fun to look at. And then vocab, being able to use the terminology that we use. Not using words or talking like you normally talk. Being a little more formal. All right? Alright, so back to the chats. Jake's all bruh. Okay. We'll skip Jake. Downey, I finished my slides this morning. Okay, he's humble bragging, which is good, Jake. Logan. But you can maybe start working on recording yourself. Alright? If you go over 5 minutes, just a reminder, Screencastify only has a 5-minute limit. You would have to make it into 2 parts. So you would have to go into present, this slide, this slide, this slide, this slide, this slide, this slide, blah, 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 blah. Then you go to Screencastify and hit stop, get the link, put the link in for part 1, and then go back to your slides and then go to the next one and be like, blah 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 blah. After hitting record again, stop, get the link, and then put it in for part 2. So if you go beyond 5 minutes, you're going to need 2 parts. Okay, just keep that in mind. Do you need to go over 5 minutes? No. But if you do, you're going to run out of time. If you have a lot of information, 2 parts probably best. Okay? Should we label which link is for what? You can tell me what, that would be good, Ryan. You can tell me what slide it was for, but I can also just check your research table. If you put it on each individual slide, that's also good. So if you put it on each individual slide, you don't have to tell me. If you put it all at the end, you could tell me slide 1, slide 2, slide 3, right? Well, slide 2 and 3. You wouldn't use the source for slide 1 because that should just be your name of your planet. Oh boy, memes. I said applicable pictures. Here's the problem with the memes. And Miss Kildoff can back me up. She's still watching. Is usually when I allow one meme at the very end, people go overboard. Humor is useful. You want to have one at the end? Fine. You start putting in 1,000,000, we're going to have a problem. Because I did it for Pluto. So, I guess it's fair. It's got to be relevant, yes. Like, it can't just be me. Like, just me. Which I've heard Ryan has done before. Kevin has done before. Where was I? I went through the rubric. Alright, so that's the overview of the rubric, overview of the assignment. You are finishing your slides. If you're done, start working with Screencastify. Practice using it, practice recording yourself. Alright, you need to have the LinkedIn presentation, and this is due tomorrow before midnight. It's not due tonight. Alright, it's not due on Thursday, it's due before midnight. Alright. If you finish early, then all you got to worry about is your DNA for the rest of the week. Thursday, I'll take some volunteers through a Google form, and we'll look at some of your presentations. We'll listen on the stream. So you guys will take over. What else did I miss? Ava, for interior of a planet, why did it say that for Earth? I'm not doing Earth. Because you can compare it to Earth. Earth has a crust, a mantle, an outer core, and inner core. Does your planet have an outer core and inner core? For extra points, it wouldn't be extra points, but it would help you in the rubric. So you can't get a 25, but it would help you. Minecraft Education Edition. What about it? Do I have to? You don't. You should, Ava. So hopefully you are all working on the slides. You got questions while you're working, you can ask them. Again, I think I addressed everybody in the stream. If you're watching without an account in chat, you can email, you can use Remind. Can you copy and paste onto the slides? Well, you can, but here's the problem. Their source is there. It's implied it's a quote when I see their source. So they can copy and paste it on here, but here's the issue. If they're going to write a narration or an explanation, Ms. Kildoff, they are fine because that will be in their own words, an explanation of what they're reading to or what they're presenting. If they are narrating, if they're going to do a screencast through Screencastify and go through their slides, if they just read off what they just copied and pasted on the slides, that defeats the purpose. So they'll lose points. But if they copy and paste onto the slides and then they explain what's on the slide and not read from what's on the slide, then they're okay. It depends on the delivery, if that makes sense. At some point, they need to be able to explain in their own words what they've researched. So don't read from the slide. If you wrote in your own words onto the slide, you can read from the slide a little bit. If you just copy and paste from the website, you can't just read right from the slide. You would have to prep a little bit off screen. You have to write yourself a note. Think of it this way. If you just take a website, you copy and paste information from it, you put it on slides, what is the value of you presenting that information if all you're doing is just reading it for me? I need you to put your own spin on it. I need you to put your own words involved in the presentation. If it's still kind of confusing, you need something to read from, then put it in your own words, don't paste onto the slides. Because that keeps you safe. Any other questions? Nikolai, you might want to email some of your teachers because of your situation. So those of you that are good, you're working on your slides, you're finishing your slides. Tomorrow, talk a little bit about using Screencastify again. We'll record tomorrow, turn the document in tomorrow. You guys are good. I'm going to end the stream. And I'm going to move over to people who have more specific questions. Alright? So if in general you're all good, I'll see you tomorrow. And if you have questions while you work, email and remind's the best way. Alright? Alright. I'll see you guys tomorrow. Bye, Azra. Bye, Jake. Bye, Hike. Bye, Downey.